Hey guys, I'm Nick and welcome back to another tutorial. In this one we will be creating kinda a loose weaving technique with dynamic splines that we will be processing through the Vellum and then applying some of the Vellum constraints, which will be driven by of course, our lovely source spread. This example is based on just a plain grid, but you can adapt this technique to basically any shape or form you want. And also I encourage you to experiment with like that weaving technique, the pattern that strands follow, and you can get really interesting results. So definitely want to drop a geometry node, which is our main thing that we will be working with. And then of course we start with a line. This line will be our kind of main one. So what I want to do is set the direction to be on the z-axis, and this will be 4 meters or centimeters or basically 4 units long. So to center it out, we want to apply -2. So you can see it centers at 0. Actually, I think we should go with a bit longer, like 8 and then -4, again centering it. And I want to a lot of points, right? And in my example, it's set to 49. And this is made so we can drop this group by range actually. And here, let me make it a bit wider. I want to set every other point. And if we set it to be display points, or maybe point numbers, it will be easier to see. And now I can set this group type to be points, and range filter should be select one of 2. So now you can see that every other point is selected. And this is exactly what we want, because right now we can drop the transform node and we can shift these points that are in our group 1, so group 1 here, we can shift them to -0.5. And now we have our kind of zigzag line or something. And now we can use this as our strands, but let me show you something a bit more interesting than this. So there are multiple ways how you can animate something along this curve, but I think the easiest solution was actually brought by Chetal Gazdar in his YouTube video that I initially found on Lester Banks, and object along a path in SOP network. So this technique, this little trick, I found it here on YouTube in his tutorials. Be sure to check out his channel. A lot of cool stuff here. But back to Houdini, we can drop this orient along curve. Here, everything is default for me. And then we can drop this carve node and set it to extract. And then just for visualization purposes, I want to drop copy to points. And we have just one point here, you see. And then we drop a sphere, for example, and let's bind the sphere and that point to copy to points. And now if we move this slider here, you can see that our object follows the path. So what I want to do now is, of course, I can keyframe this to be 0 at frame 1, and frame, let's say 180, I want it to be 1. So in the time span of these frames, our object will follow the path. Maybe I would love it if it could travel another direction. So let's set the first U to be 1, and at the end it should be 0. So now, yeah, looks good to me. And for the sphere, we can attach any object that we want. And I will be doing this kind of double strand effect where we have 2 strands above like 2 horizontal above 1 vertical. And that's why let me drop a grid like this. Obviously orientation should be YZ. I want to set the size of this grid to be 1 and 3.35. In rows, I just want to go with 2 rows and 1 column. So it's really just sort of a line. And then of course I want to transform it, basically scaling it down to 0.03 in my case, because I really want it to be really small. And here I basically have 2 points, 1 and 2. And what I can do now is add something to these points. In my example, I use circle. So drop a circle and copy to points again. And now we are copying the circle to these 2 points from our grid. And now obviously you can see that these 2 are a bit big. So that's why we want to make them smaller. And the size that I used was 0.027, and we have them. Now if I attach this copy to points to another copy to points, now you will see, if I zoom out a bit, that these two travel along these points here. To avoid intersections, I maybe wanna set this line, my line, to be a bit smoother, because I don't like this hard edge here. So what we can do is, before orient a long curve, let's drop a resample like this, and I want to check if interpolating curves and length set to 0.03, let's say, yeah, see, we have a bit of smoothing going on here. And right now, if I will check my animation, you can see that they actually flip a bit. So this is what we want actually. Another thing that I want to do now is drop a pop network. And now let's dive inside. And here in the source first input, I want to set the emission type to points. Everything else is basically default. Let's play the simulation and see what we have. Obviously, we see that our keyframes are set to Bezier, which is not correct. So let's go to Carve, let's go to geometry spreadsheet, oh no, animation editor actually, and here let's press Command or Control A, and let's change the Bezier to linear. And right now this looks pretty good to me. I would say if now we can drop the add node, we won't see anything because we need attributes. So attribute wrangle. You may already understood what I'm gonna do. So ptid equals ptnum. And now if we run the simulation again, we can bind to that ptid. So in the add node, go to the polygons by group, by attribute. Attribute name will be ptid without add, I think. Yeah, without it, like this, and boom, we have our splines. Yeah, I don't think that they are actually kind of intersecting. I think it's pretty good. But actually we can make it even better. So if we go to the circle and before the copy to points, we can drop this transform node and we can twist them. So let's set the rotation on z-axis equal to frame number multiplied by, let's say, 50. And now if we play the animation, you can see we have this really cool twist, you know, and yeah, definitely we want to play till 180 like this. And we have one of our two strands here. Maybe I want to get them a bit bigger, like 37. Let's see how it looks. Let's see if they don't intersect actually. Yeah, this looks pretty good to me. We can go to the top view. Yeah, maybe even bigger like this. Yeah, this looks cool to me, like that. And yeah, let's play to the 180. So we have our strands. Cool. Now I want to make sure that we stay in this frame. So time shift here on the frame, delete channels, and this frame should be 180, like right when our carve ends here at 180. And now I maybe want to set these, like make them a bit smoother. So let's drop a resample again. And in this resample, I want to output interpolating curves with a length set to 0.02. But no, it looks doesn't look good to me. How about subdivision curves? Yep, this looks much better. And just let's briefly check the point count, maybe even 0.01. Yeah, now I think this should be pretty good. We don't see any of these intersections here. Anyhow, this is all procedural, so you can come back at any time and fix anything that you think should be looking differently, or if something causes issues with the Vellum, we can always tweak that. And then I want to copy and transform, and here we basically multiply, like copy a few thousand times, not like that thousand, but I think I went with 27 of them and translated them like this, and go with maybe 40. It all basically depends on how long you want to wait for the simulation to actually cook. So what I want to do is end up with some sort of a square, right? So I will be at around 25 of these copies like this, and maybe, yeah, let's go with minus 0.25 in terms of translation. Now I kind of want to center it down, so let's drop a transform. And in this particular case, I'm not that worried about like actually centering it. So let's just eyeball. Should be somewhere here, I think, like this. All right, so these are the kind of one set of our weaves, or strands actually. Now we should create another one. Basically, all I want to do is create something similar and make them go like here in this direction, like crossing our zigzag threads. What I can do is basically drop a tube, make this tube to be rows like this, and then orientation set to z-axis and merge it all just to see what's happening right now. I think we lost our tube, so let's center it in x-axis. It should be, nope, should be going here like this, and orientation should be y or no, x-axis, right? Maybe you want to add end caps just to visualize it. And now we can go to 1, 2, 3, 4. I need to see it somehow I want to see it. So I just moved it to another side and now I can see it. But essentially we want to drop copy and transform again. And all we need to do is just copy it. Of course, we should make it much smaller, right? So it kind of... And actually, we forgot one thing. We want to alternate the angle of these threads here. So in our copy to points for the wavy threads, let's rotate them 180 like this. But now you can see that they are facing, not like facing, but they are also, they went up a bit. So we want to transform the pivot to get them back down, and it should be minus 0.25 or something, yeah, like this. All right, and for our tube here, let's center it in one of our these little slots here. Obviously want to make it smaller, something like this, but I see that it won't even fit here. So that's why let's do the following. Let's set the scale to be 0.06 like this. Then let's drop a transform, and in that transform node, I want to kind of scale it on y-axis a bit, and obviously translate it back so it sits sort of centered like this. And now just, yeah, copy and transform a bunch of times. I assume we want to set the total number to be, I don't know, a lot. And in the Z translation, we want to translate it so every of these intersecting threads sits in their own, you see this kind of little island. Yeah, what we want to do is definitely kind of eyeball where they should be. And ideally they should not be intersecting with the vellum here, and this will be a little back and forth with the transform here and the copy here. So I ended up with minus 3.8343 for the tube itself, and for the copy I ended up with 0.1667 for the 47 instances of these tubes here. And yeah, right now you can see that we messed the scale a bit. Let's say it to be 0.5, and yeah, now we just wanna move them a bit, kind of like centering them like this, and for the height make them stick a bit actually like this. All right, yep, this looks good to me, and this is basically our initial shape that we can work with. Of course, we want to resample our columns, so we have sorta equal amount of points everywhere. I think 0.03 is what we need here. Yeah, and this looks good to me. Now we definitely will be merging them, but just like make it prettier. And yeah, maybe we want to drop the two groups. Both of them should be just primitive groups. This one I will call them wavy, and this one I will call straight. Cool. Now it's time to create our vellum. So I want to drop a box. Nope, I want to drop a group. And I want to create a pin points. So for this group, I want to call them pin static. I want to set it to be point group, and keep and bounding regions should be checked, and bounding object should be also checked. And here we will be using two boxes. We will boolean them, and that's how we will have the border actually. So let's drop a boolean Boolean, these two, one goes into A, one goes into B. Let's preview maybe the merge, and then let's preview the Boolean. And of course, one of them should be tiny bit smaller, or yeah, tiny bit smaller, I think. Let me just quickly preview it like this. So X and Z should be basically 1 decimal smaller. And yeah, we have our points that we want to pin, but those are not the right ones. Let's adjust the size of our box to pin basically only the last points. I want to go with sort of like 8, I think. Yep, actually even more, 8, 3. So 7.5 and 8.3, and here I can go 7.3 and 8.2. And nope, we wanna make it a bit smaller, like 8 and 6.8. Yeah. So this looks good. Now I wanna also add or overwrite my PTID at this point. At PTID equals ptnum. Just want to store it in case I need it later. And now I want to set up my first Vellum simulation. So let's drop a Vellum constraints, Vellum clause actually, or nope, it should be Vellum constraints, right? And constraint type should be string. And here's the deal. So you can see that these wavy are technically longer than these straight parallel strands that we have here. So technically, how I wanna like make them looking realistic, right? I wanna make them shorter. So that's how they will be kind of closer to each other, and it will be the shape that we are looking for. But I need 2 separate Vellum constraints here. I want a string for my wavy strands and string for my straight strands. So let's set up first of all for the wavy, or for the straight, and pin points, pin static, match animation. However, we are not animating them. But yeah, let's keep it. Damping ratio should be 0.1. Stiffness should be around 100, I think. And wrestling scale at 1. Just for now, leave it at 1. Bend at 0.01. And mass, calculate uniform. And thickness also calculate uniform. And now for the wavy, let's select the group wavy here. Let's set the mass, calculate uniform, thickness, same deal, calculate uniform, pin points, those pin static points, right? And for the stiffness, I want to set them pretty stiff, damping ratio at 0.1, and rest length scale, I want to set it to be, like 0.5 maybe. And for the bend, I want to set it to be 0.001 with the damping ratio of maybe 0.05. And now attach the Vellum solver. For this one, I strongly recommend you going with 2 substeps and around like 300 constraint iterations. And of course, connect all of these here. And this one, you want to run that for... Oh, duplicate point IDs attributes detected. Oh, what should we do? Probably in this wrangle, just set the ID to be ptnum, and yep, it fixes that. So what's the goal here? The goal here is to shorten these a bit, because this result of the simulation we are doing right now will be the end shape after our strands like shrink down to when the second simulation will be running. So for example, let me simulate a few frames here, and yeah, let's decrease this to be 180 and 180 just so I see the frames. Let's simulate and see what we got. So it's been around a few frames, and here you can see how they are all shrinking down. I don't particularly like how there's a lot of space between them, but it comes down to adjusting this band value to damping ratio set to 0.02. And then for this band, I want it to be 0.1. And band of our, these perpendicular, non-twisted things, I want it to be at around 1. And those stretch stiffness should be, I would say, let's keep it at 100. And let's see what we have. Let's simulate these. Again, just 7 frames is all you need. Oh, and just one thing that I've forgotten. You should disable this freaking gravity and wind drag at 0.3, maybe, yep, let's simulate again. So after a bit back and forth, I ended up adding this resample node here and resembling it to be 0.05 in length and treat polygons as interpolating curves. And also for the strings, for the straight strings, I actually went with stiffness set to 1 multiplied by 100, damping ratio 0.1 actually, and stiffness at 0.001. And for my Vellum strings, my baby strings, I set it to be wrestling scale at 0.4, bend stiffness at 0.01. And this kind of gives me the result I want. So it's pretty flat. So we see that all of these strands actually went down like this. So the wrestling scale worked, and it's kind of, yeah, it's a loose weaving. So I really appreciate some messy result here. So after that, we want to file cache it, and file cache just one frame. So let's go set the file cache file path to explicit and disable it as not the frame range but single frame, and hit save to disk. So now we have this this one frame, and you can see that we don't have it anywhere. We just have it at frame 9. Maybe we could get, I don't know, frame 7 maybe. I don't know. Yeah, I think I like this frame 9 here. Yeah, looks from all the frames, I think that one looks the best. Or maybe let's go with 7. No, let's go with 9. All right, and now we just attach the time shift, so it's always the frame 9. So we are always reading that file cache. Let's select it, and yeah, now you can see that whatever frame it is for this chain, it's always the frame number 9. Now I want to delete a few attributes, because we don't need them actually. Attribute delete non-selected. So basically delete everything. And this time we have just the position attribute and few of our groups. Then I want to drop normals, and then I want to UV project. So we have sort of have UVs on our points and vertices. And here I want to go to initialize it to Z X plane, and yeah, hit that initialize button. Now we want to get our PT IDs back. So attribute wrangle, and let's type PT ID equals PT num. And from this point, we want to split it to two individual paths. So one would be dropping a deleting everything, but keeping the points, so we can attach our pyrosource spread to this one. And another one would be adding Vellum constraints, basically the same constraints we used, but we are applying these to all the strands that we have. Yeah, mass, set uniform, thickness, calculate uniform. Oh yeah, and for the mass, I'll obviously calculate uniform too. For the pinpoints, pin static. For the stiffness, yeah, one of them pretty stiff. For the damping ratio, 0.1, rest length 1. Yeah, all the things here, all the things are default. Maybe for the bend, I want to go with 0.01. And here, let's attach them to nulls. One should be out geo, and this one should be out con. Cool. Now let's set up the pyrosource. So I want to set the group here. Let's go group points, group name burn, keeping boundary regions bounding sphere. And yeah, want to go top view, and we are pretty centered, I would say. Let's make it smaller at 0.05. Like this. And now let's create the attributes. Let's create our temperature attribute. For the burn group, it should be 1 here, and our attribute name is temperature. Now let's go pyrosource spread, attach its temperature to the pyrosource spread. Let's visualize the temperature. Obviously our cooling rate should be 0, rate should be, I ended up going 1.2, search radius 0.4, and max neighbors at 50. And diffusion rate noise should be 0.2. Let's play it and see what we got. Oh yeah, of course, because temperature default should be 0, but the value here should be 1, because right now it's opposite. And now if we play it, yep, cool, we have our pyrosource spread working. But I want this pyrosource spread to start at some point at, let's say, frame 15. So what we can do is add this node called switch if. And what I want to do now is test for the attribute presence. And the attribute we will be testing for is temperature. So if we plug this pyrosource into the right input of the switch if and plug the delete into the left input, nothing basically happens, because we also need to test the second input, right? And you can see that it works because the temperature attribute is there, but if we set a time shift here after pyrosource spread and set it to be frame minus, let's say 15, you can see that till the frame 15 we are using this left input because there is no temperature attribute present. And after frame 15, you can see that on frame 16 we are getting this input from the pyrosource spread because there's temperature attribute right now. That's how you can kind of offset different pyrosource spreads. Let's set the visualization to be none and let's add a color. Let's make this color to be equal to the temperature. So ramp from attribute, temperature, and let's bind it to be from 0 to 5, for example. Right now, if I visualize it, you can see that we have a little blob of white color here, which indicates that these points are burning right now. They are hot. I want to also add a slight attribute blur of my color. Let's set the attribute to be CD color. And this will control how steep the curve, not the curve, but how smooth or how harsh the points will be jumping to their kind of destination, which is that frame that we just exported from the Vellum source. In my case, I wanted a pretty like smooth blur, which is very organic. So blurring iteration set to 120, step size to 0.8, pin bordered points unchecked, and influence type set to proximity. And now you can see how blurred it is here. Yeah, like this. And then I want to drop the null and call it out burn. And now we have everything to drop the .NET work and dive inside. So let's drop the .NET, and here Vellum solver, Vellum object, Vellum source, subpass goes to the out geo, constraint subpass to out constraints, out con. And yeah, this is already a working Vellum setup. We just need to add a few more things here. So first of all, we want to add some pins. So pin, no, it's not like that. It's Vellum constraints. And here let's set the constraint type to be pin to point, pin to target actually. And here I want to set the pin type to be soft, and I want to match target animation checked. And here I want to, this output group, I want to call it pin stretch. And for the bend, I don't think that I will need that bend here, but yeah, whatever. Also set the damping ratio of this one to be 0.01. And for, yeah, and that's it, I think, here. So the idea is as follows. We will make all of these strands much longer. We will set the rest scale to be much bigger than right now. And then we will be shrinking them down and pinning to the target only those points that are white color. For example, you can use groups. I will be just using color because that controls that with the color from black to white. I can also control the strength of the constraints. So let's drop a subsolver, which will be really easy subsolver. It just will contain of object merge, which will be our out burn, and then attribute copy here, and we are copying the color data, and mesh by attribute should be PT80. And now we should have all of our color data. If I play it at the first frame, it will turn black because this is what color we are getting from our subsolver. Now we want to drop a few Vellum constraint nodes, Vellum constraint properties actually. So here's the thing, while all of these are black, so I want my pin constraints to be very loose. And you remember we set them to be soft constraints, so they can be loose, they can be broken, whatever. I want to go one frame into the simulation and just stop it, cancel it, whatever, because then in the Vellum constraint properties you will have all your groups here. So I want to target this pin stretch and set, can get back to the frame one, and for the stiffness I can of course enable it by checking this checkbox here and use the expression. And here I want to set the stiffness to be fit 01, like to be a remap from our color, so CDR
0.0001 to 2 or to 3 maybe, actually without the parentheses. Let me check if it works at this point. And to check it, I obviously want some pop wind, and then I also want a pop color, just so I can basically see anything. And for this wind velocity, I want to set it to be at 0.1. And just for the sake of speed, I want to make sure that we are not using this time shift here. So we have our temperature spreading from the first frame, so I won't need to wait 15 frames right now when I'm testing it. So let's simulate just these 15 frames again. And it's not working. And I assume that's because we actually want to grab the color data from the subsolver, which is the first input of the wrangle, like not the wrangle, but this one, the DOP data. So what we're gonna do is add a float, which will be fcd float color data, and we will grab that from the first input. So the point function will give us the attribute we specify, cd, from each point of the first input. And now we can bind that to the stiffness, fit01, fcd 0.000001, 2, 3. And let's maybe try it right now, where we will have it. And now you can see that we have this little blob that is not that affected with wind, right? So how about we also make all of these strands longer, so we have more of that inflation going on here. So Vellum constraint properties once again, and this one will be for the stretch group that we have already. And we kind of can use the same thing here. Use of expression, and now we want to manipulate the rest length scale. So rest scale should be from 2 to 1. Let's also maybe decrease the wind so it's not blowing that much, because right now nothing will prevent these strands to fly completely away. So turbulence, maybe let's set that to be 6, and swirl size maybe 3, like that. Or no, actually mine 0.6 swirl size should be smaller, actually. Yeah. And yeah, let's simulate 15 frames again, and I don't see it expanding. Probably we should go back to the Vellum constraints and specify that we want that output group called stretch, right? So let's re-simulate again. Yeah, so this is what I'm talking about. So now you can see that we have the wind, it affects all of the strands, and all of our strands are definitely longer than they are initially. And we have our strains going like this, you know, you can see it here. So where there's the burning points, we have the white color, and white color means that we are getting our strands back to their positions, and we are also decreasing the rest scale. So basically that's the whole effect. What I want to do is a few modifications to get it done right with my pop wind. I want the activation to be until the frame 10, with the swirl size to be 1, amplitude to be 0.4, and maybe also add pop drag here. And I want this wind to, what I want is to actually start the simulation of my strands after frame 15. So that means that we should enable this time shift here. You can see right now my Vellum solver is at 1 substeps, 100 constraint durations. For the sake of this tutorial, to make it faster for me to file cache certain frames, I will leave it at this. But when you will be doing that, I think in my original one, I went with a 2 substeps, 200 constraint durations, and also 10 post-collision passes. But anyhow, after our DOP network, we definitely want to drop a file cache node and cache it out. I won't be caching out 180 frames. I think I will cache out sort of like 35 with the explicit file path and hitting this. Oh, no. Wait, actually I can get that color later, right? So save to disk. I've simulated a few more frames here, so you can see how it actually, like, it expands, the wind kicks in, and then when wind dies, we still have a subtle bit of motion in these strands, but then we are growing that part with our pin to target constraints. And of course, we want to set the color back to white, so it's not that, like, I don't know what that color was, but anyhow. And this will already look good, but we need a bit of these, little secondary strands that will be sticking out of our main strands that are here. So how are we gonna do that? Of course, we have normals, but we wanna alter them a little bit. So we want to drop the poly frame, and I will explain you why a bit later. And in this poly frame, we want to uncheck normal name, and tangent name should be normal right now. Now we want to delete everything, but with a little twist. So delete selected should be checked, points should be checked, add that shift 8 multiplication sign or whatever it is. And then I want to delete primitives, because keep the points, and then from these points I want to again delete everything. Now points by random, and then after that delete. When we have all of these beautiful points here, what I want to do is drop a group, and this group, let's call them active BT, and keep by random chances what we need. Group type obviously should be set to points. Let's visualize it, and we have 50% of our points selected. We can get it back to like 5 or 100, whatever. Let's keep it at around 50 or 60 something. And what I want to do now is spawn little lines on these points. I know this tutorial is probably already a bit long, so I just want to copy paste from my setup a few lines with kind of attribute noises where the attribute is positioned. So basically these are the lines that are like this. I mean, I'm not sure if I wanna or need to cover how to create these lines, but yeah, it's just a line with a vector attribute noise. And here you see that what I have, just really random things there. But what I want to do is spawn random copies of these lines to the points that we have selected. So probably I want to delete all the non-selected, right? So active PT, delete non-selected points, and boom, from this amount of points we got to this amount of points, which is much less. And now we drop the connectivity after our merge. Let's keep it at class, whatever, into attribute from pieces. Be sure that piece attribute is class, as it is in connectivity. Mode set to random. Delete goes into the right input of the attribute from pieces. Connectivity goes into the left input attribute from pieces, and copy to points. We connect the connectivity and attribute from pieces to this one. And if we select copy to points, we have hella lot of these little strands, and this is too much only because in the copy to points we haven't specified our piece attribute, which should be class, and then it won't be spawning all of these 4. It will be just spawning that one random that is provided by attribute from pieces. And then we can attach null and say that these are our out strands. We should not select it visible right now because we wanna, at this level, in this geo, we want to render our primary strands, and then we drop another geo, and then here we just go object merge and merge our out strands into this geometry. All right. So I think that's how we create these strands. Now, obviously, we want to add camera. Our camera will be 1080 by 1920 with a focal length of 125. Let's select it and let's move it into its position. I would say maybe this angle will be good. Yeah, like this. Yep. Now I also wanna add a slide dome with my favorites here in the resources, Brown Photo Studio. Saturation set to 0, enabling viewports, we don't need that. Environment, background environment, also don't need that. I just want to maybe drop a grid, pretty big grid, translate it down a bit like this. And yeah, I think now we should just kind of create a few preset, very default materials just for the first render, and then we will go through the materials because there are a few interesting things there also. RS materials, redshift material. So connect this one and let's copy this 3 times. This last one will be background material. The second one will be little strands material, and this one will be strands material. Just want to make sure that roughness is set to around like 0.2, 0.3. this background material, I know that it will be just pure black with a big roughness at 0.4 maybe. For the little strands and strands, let's just keep it at default right now, and let's go and attach them. So for my little strands, I want to set that material to be little strands material. For my like default strands, it should be strands material, and for the grid, it should be the background BG material. And for my, let's also name them correctly. So strands, little strands, and background. I know that for my strands, I want to render them obviously as strands, cylinder, max tessellation set to 4, global scale multiplier at 0.6, yes. And for the little strands, same thing, but rendered at 0.1. Alright, so be sure you saved your project, and yeah, let's set the new pane tab type to be Redshift render view, and let's check our camera and let's hope for the best. And I think we have it. Yeah, this looks pretty cool. The only thing here I don't like in particular is that we have one strands thicker than other. So what I want to do now is for these strands here, I want to ignore the p-scale attribute and set the default global scale multiplier to be 0.001 and check what's up with the p-scale there. So maybe that's because of the resample that we applied previously. But anyhow, I also noticed that we have our background not black, but like some sort of a gray, and we definitely don't want that. So let's decrease the roughness. And for my strands, yeah, I think I want to go with 0.6 and ignore the p-scale attribute checked. Let's just see how it looks. I want to, like right now, I want it to be really thicker than it should be. Almost. And I think we are at it. I see some rough edges here. Maybe we, after our file cache, maybe we can drop the resample also. So after our file cache, resample should be after our color. Let's just check what's going on if we have it at 0.02 and with subdivision curves, and we want just small part for a preview. Yeah, this looks better. There are not so many of these rough edges anymore. All right, and I know this probably looks a bit too thick, and I will show you how we can make them look more realistic, but actually I want to push them even more at around 0.8 for these, actually. Yeah, like this. And let's not forget about our small little strands. Let's turn them on. And that was a bad idea, because we wanna go back to strands and make sure that this resample goes like after the color, but not in the chain with the polyframe, because then we will have heck a lot of points. Like right now it's even at 3 million vertices, so yeah, might be hard to simulate, not simulate, but actually like display. Let's right now just check again these little strands. Yep, this is basically the scale I want. Just let's change the strand type to cone. I think that will be better. This will like make it all not look too even and too CGI-ish. Yep, this looks even better. And now let's also enable our strands, like main strands. And it's very hard to see once it's not rendered, but all of these, you see here, all of these little strands will actually add quite a lot. I won't be making them larger right now, but we'll see when we add the proper materials here. So for my strands, and I wanna uncheck these little strands for now, just to be faster, and these two go here. So the main thing here is definitely the bump map. So max on noise is what we will be using, and bump map to convert it to bump. So now if I set the noise, input should be UV vertex attribute, and let's plug it into the bump map, and this bump map, let's plug it into our material. I think I wanna also get my camera to, you know, somewhere to the edge where I can see very close up the individual strands, like here, for example. Let's reload the render. So these are my strands, right? And now set my noise to be 1.3, 0.2, and 1. And the thing is, these UVs are so stretched. If I set the Y to be like 0.0001 for this noise to be some sort of a uniform. But yeah, I would say, oh, this looks nice, by the way. I want it to be really stretched out. So setting Y value to 0.1 and X value to 1.3 will give me these sort of strands, you know, and we can decrease the contrast probably and overall scale, make it even smaller, maybe at 0.5. And let's plug that into the bump map. And this bump map, oh no, it shouldn't go there. This bump goes into bump. Yep. And this sort of extreme bump map will give me the desired kind of irregular effect. I can go with like 3 in a high scale if I want, but it's counterintuitive. So at 0.01 or 001, you can see that we still have these bumps, right? But it's not that prominent and not that much as I want. So I will go at 0.01, but that's not all actually, because I want to add another noise. And this noise, I want to make it like to displace the geometry we have in the sort of chunks. So I will be using the displace turbulence here. And for the overall scale, I definitely want to go with something like 2. And for this X scale, I want to set it to be like, I don't know, probably even more. Want to go with scale at overall scale 10. And then this one should be 0.01. So it's also stretch, but not that dramatically. A bit more contrast, and maybe, I don't know, yeah, I think this looks good. Yeah. And this bump map now, if I set it to be 0.4, you can see how much of these artifacts we are having. But actually, this is sort of what we want. And now I want to drop another RS bump map. Goes to the texture, and here's this RS bump blender, and this will blend 2 of our maps. So bump input, nope, this one goes to the base, and this one, the new one, goes into the bump input 0, and this out displacement goes into the bump input. And now I can set this blend weight to be around like 0.498, and we see how this all is looking terrible. But actually, let's just zoom the camera to where we want it to be, and I assume it was somewhere like this, and let's restart the render. And in my opinion, despite of this not having like the right shaders, but this looks better than it was. And the bump map, which technically is not correct, is actually the right one. We always can decrease the scale to be like 0.4, and maybe for this noise set it to be like, I don't know, a bit smaller, like 6. But yeah, this to me looks much better than it was. Now, maybe we want to decrease the global scale multiplier of our strands to be like 7.7, of course. And I think we can colorize them too, right? So let's go to the material network. Let's grab this noise here and let's attach RS ramp. Let's go input into RS ramp, and out color should go in the diffuse color of our material. And for this ramp, source should be UV map, or actually no, should be auto, I think. But the main thing, we can play with a very different gradients here. I think UV map with the horizontal projection was one thing that I did, or with the diagonal, radial, circular. Nope, I think it was this horizontal. And you can basically paint them what you want. I would love to up the roughness maybe a bit to 0.5. But yeah, essentially, I think that's it. Of course, we want to colorize our little strands. Just for the sake of speed, I want to bypass this rump and use just the noise. And for my little strands, I think the gray color will be perfectly fine. And now, because of the displacement map that we used, we will also have thinner lines than they are actually set to be in the global scale multiplier of the strands parameter. So you will see these little strands a bit more. Or if you want, you can always just make them bigger just by scaling them. I know they all are different in length. Maybe transform with a scale set to 2 will do the trick. Yep, definitely looking a bit better with all these little strands here and there. Yeah. But overall, I think... oh, I forgot one thing that I promised. So what we can do here is after our file cache, we still have our PTID, right? Yep, we have it. So copy, or maybe we even have our temperature. I'm not sure. Yeah, I don't think that we have it, but we can copy 2 points. No, attribute copy. We can copy this attribute here, our color data. We can copy that. Obviously, I want to stop the render right now because it will be bugging and lagging. But yeah, after file cache, we copy the attribute color, match by attribute PTID, right? And now remove all of our little strands for now. We can also plug that copy that color here and remove this color and just plug the resample after attribute copy. But basically this is also attribute blur, I think. Yeah. CD method blurring iterations 100. I don't know. Why not? Proximity, and then the resample. Pin border points obviously unchecked, and then the resample. And here you can go into the material network, and for the strands we can grab the RS point attribute. Then this out color goes into the overall opacity color, and then if I fire up the render and probably remove the background, you can see that we only see this part that was burning right now, that's white. This is if you wanna kind of spawn these threads out of nowhere. I actually like the fact where we have this chaotic stuff going on there with all the strands flying away. So yeah, I'll get all of that back, and now it's just applying some post effects. Of course we wanna apply the bokeh, right? And this bokeh should point here if I'm lucky to yeah, nail down. And let's set this a bit stronger so it's more like a macro shot, right? Photographic exposure, yeah, I don't think that we need it. But overall, yeah, I think that's it, guys. It's a pretty interesting effect that I'm sure you will find a good usage of, and be sure to experiment with everything here. I mean, the strand thickness, the strand type, how they weave each other, how much rotations they do, so you get different, you see here they kind of twist, and if I set less rotations, there will be less twists, obviously. But yeah, overall, that's it, guys. I hope you enjoyed it. I hope you learned a lot of new things. And of course, in case of any questions, please feel absolutely free to reach out to me on Discord or send me an email. Patreon messages are maybe not the best place because their communication kind of system sucks there. Sometimes it doesn't send me notifications, sometimes there's even no notification badge. But other than that, you are very welcome to reach out if you need anything. But I'll be back next week with another tutorial. Bye!